Okay? According to my notes, we are on practice test 2, and we are on problem 4E. We're ready for 4E. Okay, so what am I going to do first?
Combine the law.
Fix my table. Yes, I need to combine the logarithms.
English last period today, guys.
All right, how do I combine these, guys?
Log 3x. 3x plus 2.
3x plus 3, absolutely. Why is that 3x plus 3? Because these are added, so these two things have to be multiplied, and that means distributing 3 times x plus 1. All right, now the problem is manageable. You can't do anything until you combine these, okay? That has to be step 1. Once they're combined, now we can figure out what to do. What are we gonna do now? Loop-de-loop, absolutely. Anytime we see just one logarithm, we think about loop-de-looping. So 4 to the first equals 3x plus 3. What's 4 to the first? 4. So then we're just going to solve our equation like always, and I got 1/3. All right, everybody follow all that? All right, next one kind of looks the same. All right, what are we going to do here? Same thing. You cannot have this. You can't have both of these over here. So we're going to put it together. And what's it going to look like when I put it together? These two put together. What is it going to look like here?
18x.
18x plus 9.
Log equals log.
Now, a minute ago, at this point, I loop-de-looped. Does everybody see that it doesn't even make sense in this problem? What do I have? I heard somebody say it. I have log equals log, which means what? So 18x plus 9 equals 3, 18x equals -6, and x equals 6 over 18, which reduces to -1/3. Now, believe it or not, that is not extraneous. Do you remember we ran into some that were extraneous in our notes? This one's not, because what happens right here when I put in -1/3? What's 2 times -1/3? Yeah, if If you don't know that, you're gonna have to type it out in your calculator. I'm not gonna tell you. It's time for you to think. Negative 2/3. And then what happens when I add 1 to negative 2/3? No. It's a negative 2/3 and a positive 1/3, which is a positive number. So this, even though x is negative, this whole thing is still positive, which means it's okay. I need this to be positive. It is. I'm good to go. So don't cross it out just because it's negative. Do we cross out sometimes when they're negative? Yeah. For example, if this would have come out to be -1, just -1, what happens? What is this parentheses if I put in -1 for x? -1? Can't be negative. You can't log a negative, right? So that would be extraneous. But as it is not. That one is good. Okay. All right, let's see. All right, Luke, Eli, and Charles, I need to see you after class. Okay, let's look at the next problem. All right, so we have ln 2x equals 3. Okay. We don't have to combine anything this time, do we? All right, so that's good. What do you think we should do? Loop-de-loo. Now, loop-de-loo would be awesome, but I don't have a base. What is it? It's not base 10. Base E. So this is log base E. Remember, this right here means this. So now I have a base. So loop-de-looing says E cubed equals 2x. So what's x? What do I have to do? Divide by 2. So E cubed divided by 2. And remember, you're allowed to leave e's. Unless somehow, in a word problem, you probably want to get an actual decimal. But certainly here we can leave E cubed divided by 2. Now this is in the no calculator part. That makes a difference. Because I know I'm tempted to log both sides, but not without my calculator. So what should I do? Four and 32 are not random. They have a relationship. What is true about 4 and 32? They're both powers of 2. Alright? Now, if you're not sure about, I heard somebody say they're both powers of 4. What are the powers of 4? What's 4 to the first? 4. What's 4 to the second? 16. What's 4 to the third? 16. Okay. Is 32 in that list? So it is not a power of 4. Okay? Can't use 4. If that were a 64, you could definitely use 4. So if you can't use 4, then you're going to have to break down to a smaller number than 4. The only choice that makes any sense at all is 2. Because we know that 4 is 2 squared. Now, if we did this, 2 to the second, 2 to the third, 2 to the what would be 32.
To the fifth.
2 to the fifth, 2 to the fifth. And some of you know that because we keep using the same numbers over and over again. But if you don't, you can type it on your calculator, 2 times 2, times another 2, times another 2, until you get to 32. Now, once you've got them both like this, 2 to a power, then what can you do?
Cancel the base.
Set the exponents equal, and x equals bypass. Okay? Alright, still no calculator. Now we're gonna write as a single logarithm. Now, that's what that means. 1 log and then something. Okay? So, what do you think is gonna be in that parentheses?
X squared. Y
I heard an x to the second,
to the third.
and a y to the third, and what do I put between them there? Multiply. So I'll put nothing there, which means multiply. You can put a times sign if you want. So why is it x squared? Because there's a 2 out here, and that's an exponent. And same thing here. That's a plus, so I'm timesing. If that had been a minus, it would be x squared over y cubed. This one's the opposite. That one I'm going to take apart. And when I take it apart, I'm going to have 3 logarithms. Because I have to have an x, a y, and a z involved in the process. Now there's no exponents, so I'm not going to have any numbers out in front. If this had been a, oh, you're a big fan?
That, and we're gonna need a box fan too.
Derek, would you grab that box fan and give it to me? Thank you.
Good job.
So, if there had been a squared on this x right here, then we would put a 2 out in front of the logarithm. But there's no exponent, so this is all I got. And what's gonna go in between them? Watch it, be careful. It's gonna go plus, minus, because what's happening with the x and the y? They are being multiplied. The z is being divided. So if you put them in this order, if you have x, y, z, then this is a plus and that's a minus. Because x and y are being times and y is being divided. Okay. All right, now we're gonna get our calculators out. And we're going to do some calculator work. Okay, so here we go. First problem. Your job is to solve that. Figure out what x equals. What do you think you should do first? I heard loop-de-loop. That is always my gut instinct when I see a logarithm sitting there all by itself. I'm gonna loop-de-loop. Okay, so 5 to the x equals 10. Now there will be some goofball who says x is 2. No. 5 squared is not 10. In fact, can you do 5 to a power and get 10? No, not with whole numbers you can't. So what are we gonna need to do? Since we can't get a common base,
Do the power.
we're gonna need to do log on both sides. we're gonna take the logarithm of both sides. I'm gonna say it again. Why is that absolutely magnificent? Because this guy comes down. Now it's x log 5 equals log 10. And why is that so cool? Well, now I can get x by just dividing. So x equals log 10 divided by log 5. And then I go to my calculator and I type it in. Now how am I rounding? Doesn't say. Let's go to the 1,000. I think that's what it said yesterday. So 1.431. We just gotta read those directions. I promise there'll be directions on the test. So we just gotta do whatever it says. So 1,000th is 3 places, 10,000th is 4, hundredths is 2. This is the problem. That if you remember, we did these a little bit tricky. You remember doing log 10 divided by log 5, log this number divided by log that number? You could do, that's what we ended up doing. You could do that. If you remember that change of base idea, you always can take the log of the, I call it the top number, over the log of the bottom number, if you have an expression like that. Okay? All right. Next.
Divide by 3.
Divide by 3. You always got to get rid of that number. If this were an 8, life would be perfect. It's not. So what am I going to have to do? Now what?
Bring the x.
Bring the x out. That is what we love doing. We bring that x out because now all I have to do is divide. So go to my calculator. .322 if I'm rounding to the 1,000.
Yep.
All right. What do we do with this?
Divide by 5.
We're going to divide both sides by 5 to start with. Always get rid of that extra number. So e to the 0.13x equals 12/5. Now that variable is still up there, right? I gotta get it down. The only way to get it down is to use logarithms, but instead of LOGing, I will LN because of the E in the problem. And that just makes my life easy because that's gone. So 0.13x equals LN 12/5. And x equals ln 12/5 divided by 0.13. Yep. 6.734. All right, so right now, everybody's working on, now we're on part 8, right? So everybody is going to read each question, there's 3 of them, and you're gonna write down the formula that you're gonna use. All right, so let me put the formulas up there on the board. You are all gonna read all 3 problems right now and decide which formula you're going to use. And then we'll touch base and make sure that you're ready. So here are your 2 formulas.
Oh, that's what that's, yeah. I just said A, not B.
You said for 8?
Yeah, I think that.
You said it's right down
Oh.
All right, here we go. What'd you say for 8? A.
The second,
That one right there?
yeah.
Why'd you say that, Willow? You're right.
Cause compound monthly.
Yep, compounded monthly. Perfect. Compounded monthly. Awesome. All right, would you put down somebody besides Willow? She's got this nail. Let's give somebody else a chance. Somebody else tell me what you put down for number B or letter B. The second one again, and how did you know? Compounded quarterly, absolutely. Alrighty, and then how about the third one?
Hurt.
Hurt? And why did you know that third one was hurt?
Both constant.
Not money, and if
Constant.
it's not money, it's going to be hurt. Alright, so everybody good with that? That's gotta be step 1, because obviously if you put down the wrong formula, you're going to get the wrong answer. Alright? So we good with that? Alright, next. Let's go back and see if we can plug some numbers in. A. What interest rate is required to double an investment in 11 years if the interest is compounded monthly? Now, there is no specific amount of money that you are starting with. Would you agree with that?
Yes.
All we know is what? Whatever we started with, we're gonna end up with double it. So, pick a number. What do you wanna start with?
8,000.
Pick a number.
8,000.
3? Willow wants to start with $3. She's a big investor here. She's gonna start with $3. And then we know that she's gonna end up with $6, right? You could start with 100, end up with 200. You could start with 5, end up with 10. It doesn't matter. When they don't tell you where you're starting, but you're doubling or tripling or something like that, just pick a number and then double or triple it or whatever. All right, R is my unknown. Would you agree with that? I don't know R. I do know N though, because it says I am compounding monthly. So N is 12. And I'm doing it for 11 years. So my exponent is, 132? Now, I want you to look at this situation. Are logarithms gonna be a part of this problem? No. When are logarithms a part of the problem?
When it's in the X.
When this or this has the variable. Do not put logarithms into this, it will be not fun. So, what are we gonna do? Well, what is the first thing we would do anyway? Even if we were gonna use logarithms, the first thing we're gonna do is
Divide by
divide by 3.
Push.
Okay? Now, I gotta get R out of that parentheses. What am I gonna have to do? No. What do I do when I have a problem like 2 equals x squared? What do? I square root, right? Because why? When I square root, that power goes away? All right, so what am I gonna do over here? I'm not square rooting, I'm going to 132th root. I'm gonna take the 132nd root of both sides. Because guys, that is the only way to get rid of that exponent. And if I don't get rid of that exponent, I'm not gonna be able to get R out of the parentheses. Okay, so let's not panic. We're gonna go to the calculator in a minute. But let's look at what we have now. We have the 132nd root of 2 equal to 1 plus R over 12. Would you agree with that? That that's what I have now? Because when I 132nd rooted, all that went away, and I was just left with that? Correct?
Yep.
Okay. Now, forget the numbers, we're going to go to the calculator in a minute. If I said to you, get R by itself, I need to get R by itself. What would you do here? Subtract 1. So you're going to take your 132nd root of 2 and subtract 1, and that's going to give you R over 12. Would you agree with that? Then what would you have to do? Multiply by 12. And that will be your R value. So now we just need to type it in on our calculator. All right? Now, I can't remember if we've done this before, so I'm going to pretend like we haven't. If you have a calculator like mine, one of the big fat ones, then you're probably going to have to put this in. I'm going to put this in right here. I'm going to find the 132nd root of 2. So I've got to type in 132. That is the root that I'm taking. Now, that's if you have a big calculator. If you have one of the new ones, in a minute we'll talk about that. If you have a big one, you got to type 132 in. Then go to math. Everybody, go to math. And one of your options is x root. Press that. Now you guys with new calculators, when you use that button, you can probably fill in the boxes. It gives you boxes. Somebody with a new one have that, and you got boxes, you fill them in, okay? I can't do that, so I do 132, then I use that button, and then I type 2. And you should have gotten 1.00526. All right, that isn't the answer, don't write it down. What did we say we had to do with that? We had to subtract 1. So now I have 0.005, blah, blah, blah. And then I have to multiply by 12. And that is your answer. So your answer is 0.063. which translates into an interest rate of what? I believe the question said what interest rate. So what would we say? If that was our decimal, the interest rate is 6.3%. If you put 0.063, I would have marked that wrong, but the percent is 6.3%.
Oh.
Remember, we are going to lose points for round off error. So you don't want to be rounding stuff off. Let your calculator just do it. That's what you paid for. Just let it do it. All right. I'm going to leave that one up for another minute before I have to erase it to do this one. So let's skip down to C. What is the growth constant for logarithmites if a population of 432 grows into 987 in 15 hours? So you decided this was your formula. All right, so where are you sticking things in? What's it gonna look like now?
987 is
987
equals 432
432
E to 15R.
15R. I don't know R, but I do know T is 15. Now, will I use logarithms in this problem? Yes, because where is my variable? Right? That means logarithms are going to happen, but not quite right away. What's going to happen right away? Divide by,
432.
so 987 divided by 432. Type that in and round it off, you can kiss some points goodbye. Don't do it, just leave it. It's perfectly okay. Now what? ln. Now I'm going to ln both sides. So ln this fraction equals 15R. So then all I have to do is, now subtract, divide by 15. Kids, remember, you always do the opposite, so that's a times. So the opposite's going to be divide. So that's what I'm going to type in on my calculator. 987 divided by 432. Did you get 0.055? So we just say R equals 0.055. You will find the growth rate, that's it. That would be the equivalent of 5.5%, right? You can leave it like this. That is the growth constant. All right, any question about that one? Okay, letter B. How much will be in the account at the end of 12 years if $10,000 is invested in 2.75 interest compounded quarterly? All right, what am I going to be plugging in here? What goes where? Where does 1,000 or 10,000 go?
At the B.
That's your investment. My interest rate is what? 0.02175.
Divide by 4.
Go over 4, and then 4 up here, and times 12. So my exponent's actually 48. And I'm looking for A. These are the easiest, because I don't have to do anything except type. And type exactly what you wrote. And you will have the correct answer. Now remember, this is money. So no matter what the rounding directions are, you're gonna round off to the nearest cent.
Yep.
Because that's all that makes sense with money. Is that what you got? Good? Is everyone? Okay. So the timing is not good because I don't see you tomorrow, right?
Yeah.
Yep, and then Monday, we have Christmas on the Hill, and we don't have any classes that day, right? So, Tuesday, we will do practice test 3, and then Wednesday will be your test. So what I want to do right now is, I want you to, what do you need?
I need to get in there to make sure there's no,
Oh, there's, okay. All right. I'm going to give you a problem, and I want you to figure out which formula to use. Plug all the numbers into the formula, and then put it all in your calculator, okay? All by yourself. Here we go. You do not need to write down the problem, but you should write down the formula and stuff, but here it is. Find the interest rate, compounded quarterly, if $198 grows into $321 in 15 years. All right, so there's your problem. Figure out which formula to use, and then figure out how to type it in on your calculator.
I think we should need to swap it. This one might not be my schedule.
Give him the yellow one.
Okay, bro.
And let's not be that. First one. That what you get now? I'm tripping out of this.
I need very power.
There. That was bad.
Yeah, that means you do the other one. No, like you wrong. No, because it'd be 5.
If you think you have the formula set up, like you got all the numbers plugged in, come up and put it on the board for us.
Oh, it's 15. That was that's why.
T. Because you're trying to find time.
Okay, you gotta
Keep
go,
that. Where's this?
keep going back up.
You don't know RJ. Four. What's 4 times 15?
4 times 6 is
60.
Huh? What did you say?
Keep that here, we'll match it.
Alright, let's take a look at
I put it on your
Cam's
seat. Oh, thanks.
setup of the problem. Would you agree or disagree with Cam? I think
Agree.
it's
That's what it
perfect.
says.
Yep.
Oh.
Okay, compounded quarterly means he's using the right formula.
Yep.
He's got everything plugged in where it needs to be. He certainly can take the 4 times 15 and make it a 60, right? Makes it like a little easier. This is not an easy problem to type in for sure. Alright, make some progress. Make sure this is what you're starting with though, because that's
Yeah.
correct.
Oh, that's right. Working, ain't it, ain't it? They divide out. They just, they're just,
Abby, what was the first thing you did?
that's what she did to these last time.
Yep, that's exactly what you all should be doing, is dividing by 198.
About like 198. I know what she did.
Okay, so we're divided by 198. Am I going to take the logarithm of both sides? Oh, please don't. Please don't. Instead, we know that we're solving for something inside that parentheses, so we gotta get rid of that. And how do you get rid of a power? You root it. So this is gonna be the 60th root. So the 60th root of this is 1 plus r over 4. These cancel, so all you have is 1 plus r over 4. Now, you know what you need to do. This is a number. My calculator can figure it out. This is a number. I'm gonna have to subtract 1 from that number, and then I'm gonna have to times it by 4. So I'm just gonna let my calculator do that. So to get the 60th root, depending on your kind of calculator, I'm gonna press 60, and then math, and pick the X root button. Those of you with the new calculators, you use that button. 60 goes here, and then 321 divided by 198 underneath that radical. And you're going to get an answer when you do that. Someone tell me what you got, not for the final answer, but when you 60th rooted this. 1.008,
Yes.
okay, not the answer. That's this, right? So what do we need to do now? Subtract 1, so just hit -1, okay? And then what do we have to do? I subtracted the 1 over, so now I have to multiply by 4. And my answer is 0.032.
Studious.
Yeah. Is that what you got?
Studious.
Which would equate to about a 3.2% interest rate.
Okay, this one is actually
Yeah,
All right,
they
one
did
more.
that.
I'm gonna give you one more to practice.
Did you have these instant type of questions?
All right, how long will it take to triple my money at 3.68% compounded continuously? I heard somebody say that's a PERT. Why is that a PERT? Continuously. PERT is the continuous growth formula. So if the word continuous is in the problem, it's going to be PERT. PERT can be used for money, but only if that word is present. Okay? Alright, so what goes where? I'm gonna PERT. What goes where? Do I know how much I'm starting and ending with?
No,
Nope, but what do I know?
you can pick one.
I'm ending with
Triple.
3 times what I started with. So what do you wanna start with? 4? We got big spenders in here, so we're starting with $4, and we're gonna end up with 12. Now, could you start with something else? Yes.
5,000.
And then end up with 3 times it. I don't know my interest rate, but my time, oh, no, I do know my interest rate. I don't know my time. What is my interest rate? What goes here? 0.0368 T. Am I gonna be using this button this time? Heck no, I'm gonna be using logarithms. But not until I do what? Divide by 4. So my equation looks like this. Would everyone agree with that? If I divide both sides by 4? Now what?
Log both sides.
You can log both sides, but I would prefer to ln. Log will work, absolutely. ln makes it easier because of that. So ln 3 equals 0.0368 t. And I'm just going to divide by 0.0368. It's gonna take 29.854 years. Money problems are always years. Because your interest rates are always annual.
Yeah, that's what it said.
What was she?
Absolutely, because the first thing you're gonna do is divide. And if you
Oh,
put
okay.
15 and divide, when you divide,
So
you're gonna get
it's
3.
point
That's
zero
always gonna be 3.
three, that's what I'm saying.
Triple, you're tripling. Right? So yes, it does. All right, so you know what the plan is, what Derek?
So if you use any different numbers, would you still get the same